Review 8A. These are problems you would want to try first. I'll see if I can put some solutions down here. These are problems, mainly integrals it looks like. Let's see what we got as we go through them. So the first one there, yeah, your u is going to be x squared. Your du is 2x dx. And you can move on from there. You have to put a 2 on the inside, 1/2 on the outside. Should end up with minus 1/2 cosine x squared. Don't forget the plus c. Number 5, you're integrating that. You're splitting that up into two parts. Integrating x cubed dx and sine x dx. We should write dx in there technically, but you're just integrating those separately. And I have 5/4 minus cosine 1 as a final answer. Okay, so you're plugging in 0 and 1, and so you end up with cosine 1. We would leave it like that, I think would be a good way to do that. So number 6. Number 6. Your u is going to be the bottom part there. That's kind of the more complicated part. It's going to be 1 over u du. So your u is x squared plus 4. Your du is 2x. So you have to manipulate that. I would have taken that 3 out of there originally and just moved that 3 out in front. Okay, and so I'd like to get that number out of there, whatever constant is sitting there, so it doesn't influence my next step, because I'm going to put a 2 in there and then a 1/2 out in front, and then you can move on from there. I have this as a final answer of 3/2 ln 8/5. Okay, that could be written as ln 8 minus ln 5, kind of depends. That's fine as an answer. You just have to be aware if that was a multiple choice, you could split up that logarithm. Number 7, the x minus 2. Takes you a second, but the bottom part is your u. X squared minus 4x plus 9. Your du is 2x minus 4. That makes you happy because you can put a 2 inside and a 1/2 out in front and integrate that. Should end up with 1/2 ln x squared minus 4x plus 9 plus c as a final answer. 3 sine x over 1 plus 2 cosine x. Again, that 3, I would just, it's easier for me, that coefficient, I'm just going to move that out in front so it doesn't distract me. I'm going to let my u be the bottom part again, 1 plus 2 cosine x. Your du, therefore, is minus 2 sine x dx. So I'm going to put a negative 2 on the inside and a negative 1/2 on the outside. Ends up with negative 3/2 ln 1 plus 2 cosine x. You get a plus c back here as well. Nine's a good problem. Kind of threw that in here. Sketch the graph of 2 plus 16 minus x squared. Find the exact value of that. So you're trying to figure out the exact value, or you're trying to integrate from 0 to 4, 2 plus this square root of 16 minus x squared. That you cannot integrate directly. So that would be the way they would typically write the problem. Just says integrate that. You might try different u's and so forth. You can't do that. Okay, that one you can try. That's not integral. You can't integrate that easily. And so what you have to do is realize that you have to graph that and look at a geometric pattern here. And so if you do graph that, if you move the 2 over, you should end up with a circle. So your circle is a center of 0, 2. This is where it ends up, a radius of 4. Okay, let me put 1, 2, 3, 4. And so you end up with that circle. And we're looking for the area underneath that circle. And actually not the whole circle, we want it from 0 to 4, so we want this portion here. So the idea is you would have the quarter part of a circle plus the rectangle underneath. Okay, so the circle is pi r squared, where the radius is 4. So the whole circle would be 16 pi. You don't want the whole circle there, you only want a quarter of it. So the area that we want is going to be 4 pi, 1/4 of that. And then the rectangle is going to be 8, and so your final answer is 4 pi plus 8. Very typical problem. Expect something like that on the test. Okay, they're testing to make sure that you understand that that beginning equation deals with area under the curve, and that you just don't know formulas, that you know how to use that and you understand what that means. 10, I think we've seen that one before, or something very close to that. Y equals ln e to the 2x. I can take that 2x out in front. Y equals 2x ln e. Ln e is equal to 1, so y equals 2x, so your first derivative is just 2. Second page of the 8A worksheet. Get this sitting in front of you. Your u is the denominator, your du equals 2x plus 2. So that is handy. We have that on top. We just have to put a 2 in there, 1/2 out in front. And so you get 1/2 ln of x squared plus 2x minus 3. And you're going from 0 to 1. Should end up with something like 1/2 ln of 0 minus ln 3. And that kind of struck me as weird. Ln 0 is not possible. Okay, so this answer is not possible. This is does not exist. Ln of 0, there is no exponent on e that will give you 0 as an answer. Ln of 0 does not exist. So your answer there is actually D and E. And get rid of this. Find the average value. That's your 1 over b minus a. And then you integrate. I have 2/3 ln 4 as an answer. Okay. 13. What you're trying to do, this is weird. Not everything's written out here properly, but you're trying to integrate some function. You don't know what the function is. Okay, so you're trying to integrate this function here. So whatever that is, your u is x cubed, your du is 3x squared dx. And so you would have to put a 3 on the inside, 1/3 on the outside. And you now have to integrate the g function. It doesn't tell you what that is, so what we just have to do is consider that to be capital G. And you're going to integrate that from 0 to 2. Kind of unusual here. we got 1/3. Put in 2, whatever g of 8 is, minus g of 0. So that's basically your answer. 1/3 g of 8. That's capital G. That's the integrated function. End up that. And that's the way that looks. 14, the last one there, you're integrating cotangent. Okay, the thing with cotangent, I mean, your u is the angle, which is square root or cube root of x, which is x to the 1/3. So your du is 1/3 x to the negative 2/3 dx. Looking for that to be lying around in there. It is, except for the 1/3. So we're feeling good about this. We've got to move the 1/3 in back here, and then a 3 out in front to balance that. And so you end up with integrating cotangent. Integrating cotangent, you get ln sine of the angle plus c. That's your final answer.